Welcome students, myself S.C. Kunde from Gokhale Education Societies, JDC Bitco, English Medium High School, Nasik Road. I am going to start your new lesson number 12, Study of Sound. In this lesson, we will study sound waves, velocity of sound, types of sound, and reflection of sound. You know that sound is a form of energy which creates the sensation of hearing in our ears. This energy is in the form of waves. A medium is necessary for the propagation of sound waves. Sound waves gives rise to a chain of compression, that means the place of higher density, and the rarefactions means the place of lower density in the medium. The particle of the medium oscillate about their central or mean position in a direction parallel to the propagation of the wave. Such waves are called longitudinal waves. And on the other hand, in the waves created by dropping a stone in the still water, the particles of water oscillate up and down. All of you know that when we are dropping stone in the water, that time the concentric circles are formed. And these oscillations are perpendicular to the direction of propagation of the waves. Such waves are called transverse waves. A sound wave can be shown in the form of a graph. At any moment during the propagation of a sound, we would find alternate bonds of compressions and rarefactions of the medium. That is the band of higher and lesser density. Observe the diagram. The diagram A shows the change in the density, while the diagram B shows the change in the pressure. The changes in the density and pressure are shown in the form of graph in the diagram C. The wavelength of sound waves is indicated by the Greek letter lambda, while its frequency is indicated by nu. The amplitude, which is the maximum value of pressure or density, is indicated by A. The time taken for one oscillations of pressure or density at a point in the medium is called the time period and is indicated by T. The value of frequency determines the pitch, that is high or low, of the sound, while the value of the amplitude determines its strength or loudness. Next topic is velocity of sound. The activity is given here. Take your friend to a place where there are iron pipes, example the school verandas and staircase. Stand near one end of the pipe and ask the friend to stand 20 to 25 feet away from you near the pipe. Ask the friend to gently tap the pipe with a stone. Press your ear to the pipe and listen to the sound coming through the pipe. The same sound coming through the air can also be heard, but which sound reaches you first? From the above activity, you can see that you hear the sound through the iron pipe much before you hear it coming through air. This shows that sound travels faster in iron than in air. The distance covered by a point on the wave, that means the point of highest density or a lowest density, in unit time is the velocity of the sound wave. Therefore, velocity is equals to distance divided by time. Any point on the sound wave covers a distance equal to wavelength lambda in time t. Thus, the velocity of sound is given by v is equals to nu lambda, because 1 upon t is equals to nu, and therefore the velocity is equals to wavelength divided by time period, and thus the velocity of sound is equals to wavelength into frequency. In any medium at fixed physical conditions, the velocity of sound of different frequencies is very nearly the same. The velocity is highest in the solid and less in the gaseous state. It increases with an increase in the temperature of the medium. Velocity of sound in a gaseous medium. The velocity of sound in a gaseous medium depends on the physical condition, that is temperature, density of the gas and its molecular weight. The first is temperature T. The velocity of sound is directly proportional to the square root of the temperature of the medium. This means that increasing the temperature 4 times doubles the velocity. Next is the density. The velocity of sound is inversely proportional to the square root of density. Thus, increasing the density 4 times reduces the velocity to half its value. Next is molecular weight. The velocity of sound is inversely proportional to the square root of molecular weight of the gas. Thus, increasing the molecular weight 4 times reduces the velocity to half its value. Next topic is the types of sound. There are 3 types of sound: audible, infra and ultrasound. Now, audible sound means what? The human ear can easily detect frequencies between 20 Hz and 20 kHz. Hence, sound waves with frequency ranging from 20 Hz to 20 kHz is known as audible sound. The human ear is sensitive to every minute pressure difference in the limit of hearing of the human ear are 20 Hz to 20,000 Hz, and that is the human ear can hear sound of frequencies in this range, and this sound we called as audible sound. Our ear cannot hear the sound of frequencies lower than 20 Hz and higher than 20,000 Hz or 20 kHz. Sound with frequencies smaller than 20 Hz is called infrasound. The sound produced by a pendulum and the sound generated by the vibrations of the earth's crust just before an earthquake are the example of infrasound, and sound waves with frequencies greater than 20 kilohertz are called ultrasound. The dog, mouse, bat, dolphin, etc. have a special ability to hear ultrasonic sound. Thus, they can sense some noise which are inaudible to us. Children under 5 years of age and some creatures and insects can hear waves with frequency up to 25 kilohertz. Bats, mice, dolphins, etc. can also produce ultrasound. An ultrasound scan uses high frequency sound waves to create images of the inside of the body. It is suitable for use during pregnancy. Ultrasound scan or sonography are safe because they use waves or echoes. Uses of ultrasonic sound. The first use is for communication between ships at sea. Then to join plastic surfaces together, to sterilize liquid like milk by killing the bacteria in it so that the milk keeps for a longer duration. Echocardiography, which studies heartbeats, is based on ultrasonic waves. Sonography technology to obtain images of internal organ in a human body. Then in industry to clean intricate parts of machines where hands cannot reach. To locate the cracks and faults in metal blocks.